Hello friends, we all know that universe is full of mysteries and the myths. So friends, today I want to tell about 5 myths of universe. So let's start. Myth number 1. If the universe is 13.8 billion years old, then we should not be able to see object farther than 46 billion light years away. After all, nothing can move faster than the light. The light from the sun is 8 minutes and 20 seconds to travel the distance from the sun to the earth. But there are two important points to realize there. One is that the sun and earth are not moving away from or towards each other during the light journey. The other is that the space between the sun and the earth is not expanding. On the largest cosmic scale, the universe has both of these two factors in play. Let's imagine a galaxy that were 10 billion light years away from where we are now. 10 billion years ago, imagine that it emitted light. If the fabric of universe were not expanding, it would take to 10 billion years to reach us. But if the galaxy were moving away from us, limited by the speed of light, it could be as far as 20 billion light years from us by time the light gets there. And if the universe were expanding, it could be even further. If our universe were made out of mostly radiation, we could see up to 27.6 billion light years away in a 13.8 billion year old universe. Whereas on the other hand, if it were made out of mostly matter, that the number would go up to 41.4 billion light years. And with the mix of matter, dark matter and the dark energy that we have, the expansion brings that number up to 46 billion light years distant. That's how we can see objects so distant in our universe. Myth number 2. Nobody knows how gravity really fundamentally works. The force affecting our universe, gravitation, governed by Einstein's general relativity, and the electromagnetic weak and strong forces described by quantum field theory are easy to observe and measure. The theories underlying them are separate, with general relativity describing the relationship between matter and energy to the curvature of space and time, and the quantum field of theory describing the interaction between particles occurring in the space-time. You might worry that gravity must inherently be a quantum force in nature, and that there should be gravitation mediating the interaction. You might also worry that we cannot calculate how the gravitational force or field ought to work in a quantum situation, like for an electron passing through a double slit and interfering with itself. But the purpose of science is to explain observations and general relativity. Does so far absolutely all of them, not just sufficiently but perfectly to the very limits of what we are capable of observing. Every theory has a limit to its range of validity. General relativity will break down at some points, like at the singularities inside of black holes, but quantum field theories have those limits too at the Planck scale of distances of around 10 to the power minus 33 meter or so. Gravitation ought to exist, but they are similar to photons. Real ones can be detected as gravitational waves, just as a real photons can be detected as light waves, while virtual ones cannot be detected and are just a calculational tool. Einstein's description is perfectly valid, although we hope it's someday superseded by a quantum description of gravity. Our picture of curved spacetime affected by matter and energy, where the curved spacetime determines the paths of object, is fundamentally valid in the most important sense. It perfectly describes every observation we can conceive of making. Myth number 3. The Big Bang was the birth of space and time. The universe has been expanding and cooling for billions of years. Everything was hotter and denser in the past, and if we extrapolate back arbitrarily, for we had arrived at a point of infinite density. Theoretically, this was realized as early as 1920s by cosmologists like Alexander Friedman and George Lemaitre, with the latter calling this state as primeval atom, from the which everything emerged. When the leftover radiation globe predicted by this picture shifted into the microwave portion of spectrum by the universe expansion was detected in 1960s, the Big Bang was confirmed. Extrapolate back arbitrarily, fair and you arrive at a singularity where space and time as we know then emerge from. Only that picture is not right. If the universe temperature or energies ever rose above a certain point, early on the fluctuation in the cosmic microwave background would be larger than what we observe. The fact that they are only a few parts in one leg, first measured in early 1990 by COBE, tell us that there must have been a state before the hot Big Bang, that our hot dense matter and radiation filled universe emerged from. There was a prediction was made to what that state would be in 1980s. Cosmic inflation that set up and gave rise to the Big Bang. The details of what the CMB's fluctuation would be were predicted and observed to match in glory detail what we observed by COBE, WMAP 2005 and Planck's 2010's. Inflation come before the last 10 to the power minus 32 second of inflation or so. It's still a mystery. Myth number 4. Space, time and gravity could all just be illusion. Maybe they are not fundamental, maybe they are not real. In some senses, there has been a lot of buzz about a recent idea that some of these properties may emerge from something more fundamental. Sound waves emerge from molecular interactions, atoms emerge from quarks, gluons and electrons, and the strong and electromagnetic interactions planetary system emerge from gravitation in general relativity, but an idea of entropic gravitation as well as some ideas of other scenario like qubits, gravitation or even space and time themselves might emerge from other entities in a similar fashion. But at the root of this fact that there are close relationships in the equation that govern gravitation and those that govern thermodynamics. Normally we take the point of view that gravity and particles are fundamental entities and that thermodynamics is emergent, describing the aggregate properties of a large number for more fundamental things. In fact, the law of thermodynamics do emergent from the different more fundamental fields. Statistical mechanics, gravity may yet emerge from something more fundamental, strings, loops, hairy black holes, Planck's particle or some other theoretical construct. The key, however, is that the prediction of this more fundamental idea must differ from what general relativity predicts, and that has not been put forth in any verified manner. But most importantly, gravity is not an illusion. Even if it's not fundamental, it exists just as surely as an emergent property does. And as far as space and time, they might not be fundamental either. But there's no good idea out there for what they might emerge from that connects to anything testable. Either way, space and time and gravity certainly all exist, and calling them an illusion is simply untrue. Myth number 5. It's all just a theory anyway. The Big Bang just a theory, gravity only a theory. Even the entire field of putting these ideas together is called a theoretical physics. It's not only like these are facts, truths or even laws, they are only theories. But that completely misses the point of what a scientific theory is. Facts are what the most basic element of science. You make an observation and that's a fact. You make a measurement and that's a fact. A single experiment data point is fact and we collect as many of them we can. A device set up to collect even more. When you notice that things are correlated, the relationship between measurable observation obey a particular form or equation that's a law. It's only when you can put together an overarching framework that not only explains the facts and encompasses the laws, but also makes new predictions about things. You can go out and observe that you have got a scientific theory. If you then go validate and verify your theories and push them to absolute limits, that you have got a theory good as Big Bang and general relativity. And it's true, even a theory as robust and accepted as these examples will never be the final answer. There are always more than to learn, more boundaries to cross, more questions to uncover and probe. But the best accepted theories of the day are as close to the truth of it as science can ever get, even as we always strive to get closer. Better to understand reality with all the nonsense involved with it as best as we actually can than to persist in a comforting myth. Friends, if you like the video, please like, subscribe and comment also. And if you want to see this video in Hindi language, you can check my channel and you can go also in description box to click the link and get a Hindi video.